everybody, and welcome to... Okay, this is how I'm going to sum up the entire video. Fire. So this is math.
Yeah.
So this is a math extra credit. We're doing Newton's law of cooling, and I thought instead of baking something, let's heat something to 1,000 degrees and watch it cool. Yeah.
Eating Coke cans.
Yeah.
Newton's law of cooling is U to the T, which is the temperature of the heated object given the amount of time, equals T, which is the constant temperature, plus the U subscript O, which is the initial temperature, plus minus T again, which is the constant temperature. That's all multiplied by E to the KT. K is the negative constant and T is the time.
Temperature after the duration of 5 minutes was 91.3 degrees Fahrenheit. The initial temperature after we pulled it out of that blazing inferno was 388.8 degrees. And the temperature of the ambient environment was 38.9 degrees. And the time was 5 minutes.
Well, we're solving fourth K, but it's okay.
So to solve for K, our first step is to subtract 38.9 to both sides. Left side you get 52.4, and then your next step is to subtract what's in parentheses. 388.8 minus 38.9 is 349.9. You then subtract that. You divide that by both sides. You get 52.4 divided by 349.9. That's 0.1498, and that equals e to the k5. To bring k down, you then take the ln of both sides. So the ln of 0.1498 divided by 5. Well, you then divide each side by 5 to isolate k, and you do this, and the answer would be k equals negative 0.3797.
Exactly, which was a nice round number, but in the end we got 39.076 degrees Fahrenheit. But since all this kind of took time, and since we set a timer on one of our phones, we probably set that timer a few minutes after the 5 minutes, and then one of us had to go out there and record the temperature. So the temperature could have been a lot higher than anticipated if we didn't actually wait enough time, and there's also such as the type of material. And since there were cans in there as well, they could have thrown off the heating as well. There are a lot of little tiny variables. So, I don't know about you, but I like the fire portion better.